Welcome, and thank you for having me. So let's talk about AMP and PWA and how they fit together. So yes, I work with the AMP team. I'm also a developer advocate. I work at Google. I'm kind of in the middle between software engineering and advocacy. I do a little bit of both. I've been working on Chrome DevTools before, and now I want to make the web faster again. Now the web, to me, I had some lowlights in the past with the web because I thought it wouldn't be going anywhere anymore. But if you look back, there's quite a lot the web is really good at. It's cross-platform, it's evergreen, it's secure, easy deployed, many advantages that we could never have in any other environment, or very difficult to have. And in particular, the mobile web gives us accessibility without install, which I mean not accessibility in the other term, but actually it's just an accessible way to retrieve the app. There's no storage constraints, very important when you have a phone that isn't very high-end. And it's really always up to date if you make it so. By default, it's always up to date. So also, it just costs less money to acquire users on the web. If you look at, this is just one stat, but there's a universal understanding that this is true in most cases. If you look at how much it costs to get a single user through ads onto an Android app versus acquiring a single user on a mobile website, there's quite a dramatic difference. It's very tough and very expensive to push mobile apps, mobile native apps. So why isn't everyone building for the web then if it's so great and there's so much advantage to it? Well, the problem looks like this. Well, in the content side, on the performance side, you get slow loading, really non-responsive content, and what I hate most of all is content that's shifting. You load a page, you see a paragraph, you start reading, and then the image jumps around. I hate that so much, and it's bad. On the other hand, and this is kind of an obvious one, you just have missing device capabilities to improve engagement. Stuff like push notifications, being installed on the user's home screen, having native payment support. So all of that was missing as well. So we come from this already slow mobile web that is slow for all sorts of reasons, but also because of the hardware, of course. It's just a more constrained hardware factor. To an even slower web if you add content sites that do a lot of really unfortunate things. Now, if you look at what this means, and this is probably pretty small to see on the screen, but I'm going to go to the next one because this one summarizes it. This is very new data that we just published a few days ago that another part of Google published. So before I thought the number was 40%, but the actual number is 53% of users bounce from sites, meaning they will click away from sites that take longer than 3 seconds to load. Which means that you just lost half of your audience if your site takes longer than 3 seconds to load. Well, how many sites take more than 3 seconds to load? Turns out it's a lot. So that's the current scenario. And this, again, comes from the same study that we did at DoubleClick. 214 survey requests per mobile web page. 50% are ad-related. It's 19 seconds is the average mobile page loading time, and 77% of mobile sites take longer than 10 seconds to load. 10 seconds to load, by the way, is the threshold where everyone clicks away. So that means that 77% of all pages will never, ever be seen, which is really sad. So how do we fix that? Well, if you've been a developer for a while, you probably know the basics. No megabyte-sized images, no render rate blocking acts, no 100K lines of JavaScript. And you might now think, well, I mean, duh. I'm not stupid, am I? I mean, is it because developers are dumb? Well, not really, no. It's because we have this monetization model on the web that the internet is supposed to be free. There's no other built-in monetization model. So the only monetization model we had for a very long time was the ads business. And while that's definitely a way to make money, it's probably not the only way that should be there. And if you abuse it, which I think a lot of people have done in the past, you end up in a very desperate scenario where you add all sorts of ads and you try to find out what sticks, and you get more and more aggressive. So it's really not you, the developer, who's causing the issues. It's your manager that says, well, I really need that new beacon installed because otherwise we're not going to make the money. And so you're forced to say, well, I think that's a really dumb idea, but okay. So I don't think it's a problem with developers. So on the one side here, you have monetization and user acquisition versus the user experience. And that's is not really a good place I want to be in. And it's even worse in the CSS, HTML, JavaScript world, because if you give people access to what's happening on your page, right, there's no real containment system except maybe iframes. And most ads require some advanced JavaScript nowadays to run. So you really give them, it's like giving 100 people access to your home, right? Giving them the key to your home. 100 random people. What could possibly go wrong? Well, a lot. So just to visualize this, right? This is a perfectly normal website. You can actually Google this. This is actually a real domain. That's the bullshit. And if you turn it on, you get all the bullshit that you might find on new websites, on current content websites. So of course, this is kind of over the top, but I'm sure you've seen pages like that. Now, what are the solutions to this problem right now? Well, one is aggressive ad analytics and beacons blockers. They kind of fix the problem superficially, but of course they destroy the monetization model of the publisher, which means that those pages will very likely cease to exist. So not the best way to do it. Second, a walled content distribution platform that forces you into a specific ecosystem, locks you in, but gives you fast sites, fast news, whatever. That, again, kind of doesn't go in the spirit of the web. It's not really built in a webby way. We didn't like both of those solutions. We don't think those are legit solutions to the problem. So what did we think the ideal user journey was? So before going into solutions here, what is the ideal user journey in 2016? What do we want the web to be? Well, you start with a search, and you find an article, you click on it, you explore, and this is an e-commerce example, you explore the category, pick your favorite. Now this transition from the click to the page happens almost in an instant, less than 100 milliseconds. What happens next is, well, okay, I see it's out of stock. So, okay, there's a button there, and it says get a notification when it's back in stock. So I click that button. It gives me a prompt that asks me, well, do you want to allow that site to send you notifications, which is the exact right time I want that prompt. Say yes, of course, because I just requested it. And then you stay up to date. Well, at some point, I'm going into a tunnel. I'm on a train. I lose my connection, but I just continue exploring because I know that page probably works offline, even with no reception. And it does. I then, at some point, and a couple days later, I get notified by the website saying, hey, your product is in fact in stock again. So I'm opening it, I'm adding it to cart, I'm going to check out my basket, and it turns out, because I logged into that site previously, in this case, Chrome already knew about it. It signed me in automatically without me having to do anything, without me having to ever fill a login form. And then I have one tab to pay, to play as well, yes, but to pay. And because I like the experience so much, I want to engage more with the page. I think it's a great store experience, and I might want to buy more in the future. So I add it to my home screen. I'm going to access it again and again and re-engage on the go. So that to us is kind of the ideal flow, in this case, when it comes to an e-commerce application. Of course, you can adapt this to any sort of application. So how does the solution look like? Well, first thing we needed was a base entry point. That first click, right? First click you get to content, and it needs to happen really fast. It needs to happen, even on slow connections, it needs to happen under 3 seconds, as we just seen earlier. Otherwise, you lose all your audience. So it needs to be very fast, very easy to implement, mobile-friendly, of course, embrace the open web, and enable monetization. And this sounds like a crazy unicorn, but it's what we think we've created with AMP. So AMP is, in a nutshell, it gives you the ability to build beautiful high-performance web pages. And it gives you a growing library of rich pre-built components for those pages. So those are just a couple of examples what you can do. You can actually build that whole e-commerce browsing example. And basically, it's just HTML, but it's expanded HTML. So we replaced some existing tags, and we took some other tags, some high-level tags that you might use in your pages. Now, you might ask the question, why did we replace the already perfectly fine image tag with a new image tag? And that's a fair question to ask. I'm going to answer that question in just a bit. But you'll notice. So first, the AMP publishing flow. Usually, you are in a CMS situation or not in a CMS situation. You generate either one or two versions of your page. It can either be a full page and an AMP page or just an AMP page. And then the AMP version of the page gets cached by the Google AMP cache, which is a cache that sits on top of, that's not related to the technology of AMP, but just sits on top. And because AMP is a container format that can easily be cached, it will cache all of those pages and make them even faster through the Edge network. And then finally, those pages get consumed by a platform like Google or Pinterest or Twitter. And finally, the user gets to see the content. So the ecosystem is already growing and expanding. We just got Bing as a new player in the AMP space, and a few others. So all of those distribute AMPs contained in a viewer form, and many of them in a very fast, accelerated way. On the Google side of things, I'm going to go slightly into detail. We have the top stories carousel and search, which is what we started with, rich cards, news and weather app, and soon, and this is kind of important, the blue links in search, which is the organic search results. So as soon as we detect that you have AMP on your site, we know, hey, this is going to be a fast site. This is a page that we're going to recommend to our users as fast. So if you click one of those AMP pages, it opens, it doesn't navigate out, but because of its contained, easily cacheable format, it opens right there in a viewer almost in an instant. You can actually try that out today in a demo. Now, AMP pages, again, are just web pages. It's AMP HTML and CSS, no one-off JavaScript, so no user-authored JavaScript, instead custom elements. And sandbox AMP iframes give you the ability to basically do everything else that you want. So in an iframe, you can still do everything you want. And then there's the AMP open source library, which is what I usually refer when I say AMP. It's the same everywhere. So there's only one version, and it's served by the AMP CDN. And it's highly cacheable, therefore. It defines behaviors for custom elements and manages rendering and resource loading to optimize performance. So you say, wait, no JavaScript? OK, yes, that makes a lot of people very sad. And it makes me sad because I kind of like dealing with JavaScript. But we had to take some of those toys away because you can do pretty much everything in JavaScript, and we couldn't really prove that your page is fast or not. So what we have in AMP, though, are three sources of speed. One is the format, the second one is caching, and the third is pre-rendering. Now, in the format, so you have the average mobile site, and we talked about this already, and then you have a hand-tuned site. A hand-tuned site is always going to come out ahead of an AMP site, because what we do, all the performance optimizations that we do in AMP are generic. So if you have a specific use case that you can optimize, you're always going to be slightly faster than AMP. But the point is that we can do it at scale. We can do it for all of those publishers that don't have a huge front-end team that follows every performance expert on the web. So this is what we can give them with AMP. So it's really a single HTTP request to fetch the entire document. And an edge case is fonts, so fonts would still be extra. The CSS is all inline and a maximum at 50 kilobytes, so you don't need to do an additional round trip to fetch the CSS. It's just GPU optimizable animations, so transform and opacity. All scripts are asynchronous. So there's nothing on the page that would block the rendering of content in the first place, except maybe the font. And this is also important. Each static element has a predefined size. So we have a static layout rendering system, and I'm going to tell you why that matters so much in one of the next slides. So again, because of the asynchronous nature, extended component downloads, so you don't just include just one AMP file, but you include a couple ones for all the tags that you need, they do not block page load. So the page can stay render just fine, and then once the other one is asynchronously fetched, it just blends in. Third-party JavaScript is only allowed in sandbox iframes, as I already said. And this is what I just talked about when I said I'm going to tell you why the static layout system matters so much. Because it allows us to optimize resources currently in view. Without loading any assets on the page, with loading just the document, we know precisely how the page will render. We know exactly where assets will end up being, so we know what's going to be in the first viewport, and we also know what those assets are. We know this is an image, we know this is a video, we know this is some other tag, and we can reorder and prioritize accordingly to what we think the user wants to see first. Does the user want to see an ad first? Well, very likely no. The user wants to see content. So we're always going to prioritize content over third-party embeds. So then the second source, as I already mentioned, is caching. The Google AMP cache uses the edge infrastructure of Google and Google Search and any other products we're doing to deploy AMP everywhere in the world and gives you basically a free CDN that is then consumed by those platforms that serve your AMP content. And what can be done then is pre-rendering. Again, because we know what's in the first viewport, there's a very easy way for any platform that integrates with AMP to say, pre-render the first viewport, but none of the embeds in many of those pages that just appeared on, let's say, Google Search. So for the first 5 or 10 pages, we pre-render and pre-cache them, pre-load them immediately, which is why that first click feels instant, because it's so cheap to do, because the documents are so small. So then again, no third-party JavaScript is executed at a stage, so it's actually safe to do. There's no huge performance impact in order to pre-render those pages. So 3 sources of speed: format, caching, and pre-rendering. So good. We fixed that first problem. We fixed arguably the fact that it's slow loading and non-responsive, and the content is shifting. Again, content shifting cannot happen on AMP as well. There's no way that would happen. But what about missing device capabilities? Well, now we get to part 2. The user is already on the page. Sure, he gets that page. He didn't click away. That's great. He gets to see the content right away. But how do we engage with the user? Well, if you look at the web versus native in this sort of axis, you have capability and you have reach. Now, web is very, very efficient at reach. And in terms of capability, native apps have always been ahead because they didn't have to standardize. They didn't have to work with other browser vendors in the WCC to standardize on a new feature. They could just run on whatever speed they wanted. So what we want to do here is move that just slightly and keep the reach, but actually expand it so we add more capabilities once you already served something to the user. And we do that with what we call progressive web apps. And what this means is we want to add reliability, push notifications, home screen access, and then very, very recently, simple sign-in and one-tap checkouts to the capabilities that the web offers. First one is this dinosaur, and if you've been using Chrome, you know that dinosaur very well. We don't ever want you to see that dinosaur again. It's a nice dinosaur, but I think it's time. So when you're on the user's home screen, this expectation that the app needs to be reliable is even stronger than before. So there's no reason you should ever see the "you are offline" thing. How we fix that? Well, we fix that with service workers. Service workers are basically a client-side proxy that's written in JavaScript that runs between your clients, between your page and the web server. So it sits on the browser level and the client level. And it can proxy any incoming or outgoing requests. And so it can do a lot of magic, and one of those is offline access. So for instance, one thing you can do with this is create an application shell, like you would do in any native app. You create the application shell with everything required with the layout, and that cached shell then loads instantly on repeat visits because the service worker caches it, gets it available offline, which means that at that point, it really behaves very, very, very closely to what you think is a native app experience. On the second click, you see the app shell immediately. The layout is already there, which is super important for perceived performance. And then dynamic content just trickles in once you get it from the server. So then web push notifications. To re-engage with that app, we saw that earlier, I needed to send a push notification. Well, we added that ability, and we also integrated it into Service Worker. So it's built on Service Workers. You have a push subscription endpoint, and you have your own domain. And then you have a Service Worker that handles those pushes. And once you get something from the server via the Service Worker, you can then handle that push request and show it on the user's actual device, even if your page is not visible, and that's the key point. So notification looks about similar to this. And finally, add to home screen. Now, for add to home screen, you have to add a manifest to your page. And that web app manifest will basically allow you to say, this app is something that should be able to live on your home screen. And if you follow a couple of rules, which is summarized, HTTPS, Service Worker, and the web app manifest, you get this experience where you get a prompt to the user saying, hey, this app is available on the home screen if you want it to be. Do you want to add it? In the past, you had to go through a menu to do this, and a lot of users didn't know how to. So this is a huge improvement over what we've had in the past. What are the latest problems we're solving? One is that signing in is a big pain point. And in fact, 52% of users will quit before doing yet another sign up. So that means if you have a slow loading page, all right, 50% of users are already gone. And then you need them to log in, all right, another 50% are gone. So you end up with 25% of your remaining audience, and that's really unfortunate. And then 95% of the users would give up if they don't remember a username or password. So they don't, what you think, right, is that they click on forget password, they get a link, they bother to log in. No, they don't. They just don't do it. And then what we do here is a credential manager API. This allows you to sign in more easily. It's an ability to have users save info for easy access later into the browser. And then first-time users get prompts to save those login credentials in what we call smart lock. But this is just the way it works on Chrome. It could be another password manager on another platform. And then for returning users, ideally, they get automatically signed in without having to type a password. And the key here is that because it's implemented on the browser level, you don't even get to see, in the best case, the login form. So we can do all of this without ever showing the login form in the first place by just signing them in automatically. And then the other problem is that too many fields in a form lead to 97% of a checkout abandonment. So meaning you want people to pay something, to buy something in your app, and there's really no way to get them to do so if your form is too long, and again, they would bother to click off. Not what you want. You want them to buy stuff. So what we do here is the payment request API. And before I go into this, I realize that there are some unique challenges to India that might not enable one-tap payments right away. So there's still some work we have to do in India to support the true one-click payment. But the idea here is that it leverages autofill, pre-populates user information, and in the best case, if you, for instance, combine it with Android Pay, you could do a one-tap payment solution on the web that uses something like your credit card or Android Pay right on the device, because we store the credit card details, and you just get an API and a notification that the user has paid. So, which to choose? On the one hand, if you look at the data, we just did a case study with the Washington Post. AMP really helped them to increase retention. So they produce over 1,000 new AMP articles every day, and the load times are a huge improvement over before, 88% improvement. And actually, more users are returning within 7 days, which is an increase of 23% on their side over the traditional side. So really, really good numbers. Those are early numbers, and I think might get even better over time. But PWA, on the other hand, progressive web apps, also work really well for many companies, especially 2 Indian companies here. One is Housing.com. I saw a 38% increase in conversions, 30% increase in page load time. And then Flipkart, as many of you know, saw even better stats. 3 times more time spent on the site, 3 times lower data usage, and 70% greater conversion among those that added it to the home screen. So those people are really engaged. So on the one hand, you have instant delivery, optimized discovery, but no user scripts, no scripting abilities, and mostly just focus on static content. So if you build an advanced tool like Slack or Gmail or something, it's not going to serve your needs. On the other hand, you have progressive web apps, and they give you installability, they give you app-like features, but slower delivery. And slower delivery because they don't get that embedding capability that AMP gives you and the static layout system that allows the pre-render. And it's, again, not easily embedded into third-party sites. So distribution gets a little bit harder. So would you choose instant first load or native-like app? Or what if I told you you don't have to choose? So you can actually go from AMP to progressive web app. And I'm going to tell you what that means in 3 stages. Stage 1 is the first entry point to your page. Build a great AMP experience first. Now, there's a lot of components that I already mentioned available to do this. So you can all check out all of them in the documentation on ampproject.org. So a lot of it might already be available. You wanna have Facebook embeds? Well, use AMP Facebook. You want to have a YouTube video? AMP YouTube. So chances are very likely that your use case is there and already fulfilled, even without you having to write JavaScript. What you need to decide, again, is do you want to have all your pages in AMP and just use it as a library? That might actually be fine, and you might not have the use for JavaScript in the first place. Or do you want to have a full page for, let's say, desktop, and then the AMP pages for mobile? In this case, you do a paired approach where in the header of your page, you link those both pages with link rel canonical and link rel AMP HTML, which, for instance, tells search crawlers that those pages are actually the same page. It's just a different technique used to build that page. So you can do any of those things. In my case, for instance, my own website, my own blog, is just all AMP because I mean, it's a blog. I don't have any need for JavaScript on that blog. And so it works for me. Validation here is the key. So AMP works because it's strictly validated when served from the cache. Validated in so that there's actually no user-authored JavaScript on the page. So that, for instance, is one of the checks we do in the validation system. So you can do your own validation very easily while building AMP. You can just look at it in Chrome DevTools by appending to the URL, or you can have it on a web interface on validator.ampproject.org, or even a browser extension. That's really, really low effort. It just gives you a little sign saying, yeah, it's valid. And if it's not, it just alerts you. How about AMP for desktop? Well, yeah, absolutely. Yes. I mean, I guess it was kind of a mistake to put mobile into accelerated mobile pages because really you can use it just fine for desktop. It might help you most on mobile because of the low latency environment, but you can absolutely use it in a responsive way. And we actually build in a lot of responsive capabilities into AMP. For instance, the layout property that allows you to do responsive images right out of the box with a fixed aspect ratio and resizing to its parent, which is really not trivial in many cases if you do it in CSS directly. Or you could use sourceset to do art direction, to serve retina and non-retina images, and that sort of stuff. And it's actually, the cool thing here is you could say, well, I know this exists. It's already in Chrome or something. But this works across browsers. This works across all the latest versions of the last 2 browsers, which is what we support in AMP. So this works on Safari. This works on other browsers. And then you can use element media queries, which is another very cool tech, to not just have CSS decide what gets shown and what doesn't, but you can do it on a per element basis. Meaning if you want to do a one-off thing that you only want to show on mobile in one page, you can say, well, I don't want to clutter my main CSS. I can just hide that in the actual AMP element right there with media. So let's get working here. I want to do this, which is, this is actually the live AMP website. And I want to have this sidebar and this drop down to toggle the language. And I want to have this accordion functionality in here to actually click through the page. How do we get there? Well, I found AMP sidebar. Wow. So an AMP sidebar is precisely the sidebar. I don't have to code any JavaScript to do this. I just have the AMP sidebar element. In there, I have the hamburger button to close it again. And I have any other UL or something list in that element. And then finally, the hamburger in the header that shows the sidebar. And how do we show it? We have an event system in AMP on the element, the on attribute, that allows you to say, on tab, please toggle that sidebar. Again, without writing JavaScript, you just created a toggleable sidebar that works on mobile and desktop. But what about the dropdown? Well, OK, let's look for AMP dropdown. Oh, no AMP dropdown. OK, what can we do? Well, in some cases, we need to be a little more creative. In this case, there's an AMP accordion. Now, the AMP accordion, if you look at AMP by example, which is a nice page also built by one of our team members to check out a lot of cool examples with AMP, you see it's actually, I mean, sure, the accordion looks like a classical accordion, mostly. But what if we style it differently? And we have an example here with just one entry. And this looks pretty much like a toggleable thing that we might need, like a drop-down. What if then we go ahead and set the height to a fixed value, and the overflow to visible, so it just grows out of the container, which is pretty much exactly what I did. And now we get the drop-down by using AMP accordion with really just doing one small change. So that's good. Not too advanced. But how about this menu? Well, this menu works completely differently. It uses a lot of techniques to blend in stuff, and it has some styles that AMP accordion will do. So I can't use AMP accordion here. I also cannot use JavaScript, because again, I want to have my blog work everywhere with AMP. So what did I do? Well, I did something pretty crazy, which is the infamous focus hack, focus input hack. What I did is the actual menu button is a label. So the label, if you click it, is a label for nav hidden checkbox. That is a hidden checkbox that gets toggled when I click that label. So you click that button, the checkbox toggles. Now, right next to the checkbox is the actual menu. So in the CSS, I'm using the adjacent selector to say, when that checkbox is toggled, please show the menu. And this makes the on-click work to show a menu. Again, no JavaScript used, just a clever CSS hack. And we fixed it. Hey! All right. So what about optimizations? There was just a short example of how development in AMP would look like. What about optimizations? Well, ideally, you only include the AMP scripts that are needed for that page's tags. So in your post process or CMS process, you figure out which of them are actually needed. That's a nice recommendation. And then only load the CSS you need for a given page. And I say this with a caveat, which is I'm not currently following that rule on mproject.org. I should, and I will, but I'm not currently. But this is another smart optimization to do. And again, more you can find for this specific example on AMP by example. Again, lots of examples of how to work with certain AMP tags, and in even complex examples of how to do e-commerce with AMP, or whatever, hotels listings. So how about level 2? Level 2, you accelerate subsequent loads with Service Worker. So what you can do to build a Service Worker here, if you haven't used Service Worker before, quite nicely, is SW Precache, which is a library that generates a Service Worker for you. This library, I've set it up here in a gulp task. It's pretty hard to see from where you sit. But what it does is you basically have a file glob. You scan the directories for, and this says cache all those files you find on my local system. And then you also have a runtime cache section which says, if you discover something with that URL pattern requested by the client, cache that too. In this case, we cache the AMP library as well as our local assets. Because in order to go offline, we also need the AMP library, of course, being available offline. And then on the AMP side of things, we can actually install the Service Worker with the AMP install Service Worker tag. This again allows us to do something without JavaScript that would otherwise have required JavaScript. So we can point this to our new Service Worker. And the cool thing here is that this even works when you go to the cached page. So if you go to the AMP cached version of the page, let's say from the first click from a Google search result, this tag still fires, and it will cache, it will instantiate the Service Worker on your origin, which means that the next time someone goes to your page, or once you click out to another link on that page, the Service Worker on your origin is already running. So you can use Chrome DevTools on the Application tab to actually check out that Service Worker and make sure it's in fact running, and which it is. And you can look at the cache storage down below to see, OK, yeah, those resources are actually cached, and also those resources that it's meant to cache on the fly are also cached. And then finally, we get to see it in action. So you click on offline, you reload the page, it simulates offline availability, and yes, it's in fact offline. The whole page is offline, except, of course, the YouTube video, because the YouTube video requires functionality online. But I can navigate across the whole page, and it will work. So activating the Service Worker, there's one slide missing here, I think. No, OK. I think I wanted to skip those slides. But this is actually an example of how to build your own Service Worker if you don't want to follow the SW Precache example. But this is quite a lot to do right now. So I'm going to show you a link to this demo right afterwards. Again, if you want to learn more about how to do Service Worker, there's a great course on Udacity that one of my colleagues has done, Jake Archibald. And he created a course called Offline Web Applications. It's free. You can check it out. He's actually really funny and really engaging. So if you want to learn more about how to build your own Service Worker, that's really, really recommended to check out. Now, level 3, add a web manifest to trigger add to home screen banner. So in the head of your page, OK, first step, right? We already have offline AMP pages now. So now, in the head of your page, you're actually allowed to add the manifest to your AMP page. So you add the manifest to your AMP page. In the manifest JSON, you do use a couple of values, like display standalone. You set the theme color. You set the right icon for the home screen. That's really important. Otherwise, it will not work. It will not show that add to home screen banner if there's not at least an icon with 144 pixels, I think, in size. And then you see if you've done everything correctly, again, by going to the Application tab in Chrome DevTools, and then go to Manifest. And you see, OK, yeah, this is what we think the manifest looks like, what you think it should look like. And then there's an add to home screen banner, link right there next to identity on the very right. And you can trigger the add to home screen functionality and try it out right there. And if it doesn't work, if you've done something wrong, it will show in the console. So in action, and this is just an example using Flipkart here, again, you see the add to home screen banner, you add it, and it will load really quickly when you did the right tricks in Service Worker when you click it. So here's the crazy thing. Congratulations, you just built a progressive web app. Now, what's really cool about this is you built a progressive web app without writing a single line of client-side JavaScript. You build a progressive web app that is an AMP page, right? That has complete offline functionality, is secure because it's using HTTPS, using a manifest. You've done all of this by not writing a single line of JavaScript. But what if you want more JavaScript on your page? What if you want to have advanced functionality? Well, first, I'm going to tell you how to enhance your AMP pages on level 4 with the Service Worker. So one of the problems, right, is that AMP forces inlining of CSS. So a typical page header on ampproject.org is about 43 kilobytes of size, which is significant because that includes all the CSS for the page. So at 100 dogs, which is the approximate size of our cache, you get more than 4 megs of additional clutter. And on very constrained storage situations, devices, that's a huge problem if you cache all of that up front. So what if you could only cache the body and merge with the head on request? What if we just don't cache the whole page? So here's the strategy. And I have code with all of that, and I'll show it to you later. But so you get the text response on the page in the Service Worker, then cache just the body. And then you prepare a small template that makes up the rest before the body. And on subsequent client requests, you stitch together the responses to recreate a full page. And just the code that works for the stitching looks a bit like this. So you create a complete response by getting the template, which is just the body of the head of the page with the CSS in a string. And then you get the text data from the cache, which is just the body of the actual page you want to serve. And then you stitch them together. And you create a new response that is served to the client. And now what you get is the very, very same result that we had before. If you want to see the full source code, I don't have time to show you the entire source code. You can go to this link. I also tweeted it on my Twitter account, so you don't have to make a photo if you follow me. So what did we just do? Well, we optimized a lot of the caching by just writing a few lines of JavaScript in our Service Worker. And again, those are still completely valid AMP pages. They look completely the same. It's just that we removed all the clutter, all the extra code. What if I want some fancy JavaScript on my page? So I found this really nice page called Rainbow Arch Scripts. It reminded me of my first time with JavaScript in my 90s. And so I got nostalgic. I was like, OK, this is clearly something people can benefit from. So I found this really nice clock that sticks to your cursor, which will probably improve almost any page it runs on. But sad, well, we can't use JavaScript. So this all requires crazy DHTML JavaScript. I have read. So what if we just did what we did prior to that and at a third line that gets random stuff that AMP doesn't like and puts it in there? Oh, OK. Let's see how that will work. I'm going to reload. And yes, I get a fancy animating background, and I got my clock on an AMP page. Yeah. OK. So we get that, which is precisely what I wanted. But what about the AMP cache? Right? Now we have an invalid AMP page. So wouldn't that mean that the AMP cache doesn't serve it anymore to the distribution platforms? Because the validation system fails, right? Well, no. Well, first of all, yes, I shouldn't have done this. This is really bad. Don't do this at home. But you can spice up your page with anything that's actually useful. But the cool thing here is that the Google AMP cache will see the page normally because it doesn't know about the Service Worker. So it will cache the normal AMP page. And then as soon as the Service Worker comes in, consumers will see the AMP page first. The cached version of it will just look normally on first click. But then the extended click, the subsequent clicks going out from there, will show you all the advanced stuff. So this way, you have an absolutely valid AMP page that gets expanded and extended afterwards. So here's level 5, which is the ultimate boss fight. This is kind of the boss level. And so it's really alpha. What this is completely rerouting to an app-like experience, in this case, a PWA. So how would this look like on something like Washington Post, for instance? They just did an example. In their case, they use, again, amp install service worker to pre-cache a PWA app shell, even while the user is already reading an AMP page, even if it's coming from the cache. So the cache, the PWA then is already available, completely cached. And then once the user clicks out, bam, instant click, progressive web app. So you get instantly to the first content, and you get instantly to the progressive web app. Now, how does this look in action? How does this look like in the ideal scenario? Well, this service worker hijacks all navigation, and then the service worker serves the PWA shell instead of the AMP cage instead. And then the PWA shell initializes a Shadow DOM-based AMP viewer, and then the originally requested AMP document is fetched via XML HTTP request. And then finally, subsequent navigation on that PWA viewer page uses history push state and XML HTTP request to navigate within the AMP viewer only. So now you got a full-blown progressive web app with engagement features, with push notification, everything in an instant by going with the AMP strategy. So if you want to, again, learn more about this, follow the link earlier. Actually, this is another link you can follow. I think this is the same link. Yes, there we go. Oh, sorry. No, this is actually, so if you want to learn about the advanced technique here of creating this Shadow DOM-based AMP viewer, you can check out a link here on the AMP HTML repo, on the open source repo. And there's an example in there called PWA. And this PWA example has the latest thinking. It's not production ready in any way. It's really alpha. But this allows you to give you the ability to actually tinker and see how it works. So for you, that was a lot of stuff. 5 steps to get from AMP to PWA. And if you want to learn more, go to ampproject.org/docs to, you sadly have to see my face again, but I hope those resources will be helpful. And then developers.google.com/web if you want to learn about progressive web app development or any other web development best practices in 2016. And also, you can find us on the YouTube. We have a Slack channel to have you ask any questions you have when it comes to Chrome or the open web. And then finally, feel free to follow Chromium Dev for everything that's happening in the Chrome world, and my own handle to see what we're up to with AMP and progressive web apps. And now, the very slow turtle is actually a very fast turtle in this nice new environment. Thank you. And I think we have about 10 minutes for Q&A, if anyone has questions. One second. I think there's one here first.
Can I go first?
Somebody who has the mic, the first and the second row, please.
So, can we expect service workers to be implemented in, say, Safari anytime soon? And can that be like polyfilled or anything?
I think I've seen, so I don't know. I don't have an answer for you, but I think I've seen some positive signals recently on Twitter. I hope I remember that correctly.
Because only then wouldn't it truly take off if we can target all mobile platforms?
That's true. I agree. And I want to see it as soon as possible. Again, I think I'm cautiously optimistic that this will happen.
Right now it's Chrome only, or?
No, it's Chrome and Firefox and Opera.
Thank you.
Sorry, let's get the mic first, maybe.
Yeah. So in terms of during our active development, we would be changing HTML, CSS, things quite rapidly. So when it comes to caching, how will the invalidation work? Because the service worker would have cached all of your previous stuff? How do you do some kind of a versioning or?
Yeah. So the cache works like a reverse proxy, which means that every time a user hits the cache, we will fetch a new version of that page in the background. And so the next time a user hits the cache, they will likely see the new version. So it should be relatively up to date at any given time. However, if that's not enough for you, right? You want to have the most timely update available all the time. We have you can Google a Google AMP cache, and we have written an API that is just URL-based. It's a REST-based API that allows you to clear that cached version of the page immediately, which means that the next time someone hits it, it will be a completely new version. So we have built an invalidation system into the platform.
Will Service Worker will be available in Chrome browser in iOS?
Sorry?
Service Worker,
yeah.
Will it be available in Chrome browser in iOS?
As soon as Safari adds it.
Okay, it's just a reskinned or an.
So because Chrome on iOS doesn't use Blink, the rendering engine that we use in Chrome everywhere else. It has to use the web viewer on Safari, which is why we have to wait for Safari to add the ability.
Thank you.
You said Bing supports AMP now. Hey, the question is here.
Wait, right here, okay. Sorry?
Right, so the Bing supports AMP now. Can you comment on what that means? Like, does Bing now fetches the AMP cached pages and like cache it?
I think they're going to talk about it relatively soon in a blog post. Mm-hmm. I'm not completely sure. I think they have a multi-stage approach where initially, like many platforms, they just redirect traffic to the AMP version of the page on the existing origin, so skip the cache, but go to the AMP version of the page, which still gives you a performance improvement, mostly over the full page, because of the pre-rendering and preloading. But I hope they will expand it further. And again, I don't know how the exact plans look like, but I hope we'll get to see a really nice instant preload experience with them as well.
Okay, but in general, when you say that something supports AMP, it means that they will go to the AMP cached page that Google caches, and that's
not necessarily. There are multiple levels of support. One could be you just use the AMP Google Cache API to find out for any given, let's say you build a messenger, right? Messenger app. So you see that the user just posted a link. Use the Google AMP Cache API to find out for that link, is there an attached AMP page available? In this case, if you click the link, you redirect to that AMP page instead. So that, of course, isn't what we do on Google Search, but at least it is some level of integration, right? This is the first level of integration where you lead people to the AMP page instead of the full whatever page. So that's the first level. The second level, again, is to use the AMP cache for pre-rendering, load it in a viewer, and do all the preloading steps. So there's multi-level approaches.
One last thing. So this AMP page is only cached by Google AMP cache servers, or?
Right now, yes. But in theory, there could be a lot of AMP caches. We are working on opening up the documentation for what it means to be an AMP cache and what kind of security implications and stuff, what kind of framework it needs to support. So in theory, other companies will be able to build caches in the future.
Thank you.
Mm-hmm.
Is there anybody else who wants to ask a question? We will take one more question.
You mentioned about content shifting, and in order to avoid it, it's better to have a specific slot, as in like the header or the image slot. Would it create problems when we browse or when we browse the same site across different mobile devices, which has got different screen size and etc.?
No, because what AMP does, right? Every element has a constrained size. That doesn't mean that every element has a fixed width and height. It just means that we can render before we know about the asset's height and width, which means that the first layout we look at the screen width and screen height and then adapt every element to that size. So it doesn't matter whether you have a small mobile screen, large mobile screen, whatever, because it's really just about the aspect ratio of images, for instance. When you do an image in AMP, you set the aspect ratio, which means that as soon as you do the first render without the image already there, we know how much height it will take. So that's why it allows you to do all sorts of viewports. Cool. Yeah, feel free to come to me afterwards. I'll be hanging out outside and to chat about anything you want. Thank you.